Electricity. Electric charge. Charge is the property associated with matter due to which it produces and experiences electrical and magnetic effects. So, charge are of three types: electron, proton, and neutrons. Charge are present inside the atom. An atom is a molecule substance. Yeah, appearance of charge. If an atom lost electron, it have positive charge, and if atom gain electron, it have negative charge. Property of charge. First is additive charge. Total charge on body is algebraically sum of all the charges located anywhere on the body. It means that the total charge present in the body, whether it is electron, proton, or neutron, the total charge is sum of all the charges inside the body. Charge is always conserved. Charge can neither be created nor be destroyed. Charge can neither be created nor be destroyed. मतलब it means that it can change its form into one form to different form, but it can neither be created nor be destroyed, uh, like the law of conservation of mass and the first law of thermodynamics. Charge is invariant. The numerical value of an elementary charge is independent of velocity. Means charge is not the vector quantity. Uh, it have only magnitude, no direction. The numerical value of an elementary charge is independent of velocity. Velocity don't matter in the charge. And fourth, the most important properties of charge is quantization of charge. Quant means process, and quantization means process and packet. Quantization of charge. Smallest charge that can exist in nature is the charge of an electron. It means that the smallest charge which is present in the nature is the charge of one electron. Means that let's suppose electron has 2 coulomb charge. Then the smallest charge present in the nature is the charge of one electron, which is 1 coulomb. And charge of an electron is equal to 1.6 in 10 to the power minus 19 coulomb, and this is called the quanta of charge. And charge on body is equal to integral multiplier of E. Let's suppose E a number, a whole number, and a whole number, or E charge of one electron. So the formula is Q is equal to Ne. Find the number of electron present in one coulomb of charge. So the in this question you have to use the formula of Q is equal to Ne, so that after solving it, the value of charge on present in one electron is 6.25 into 10 to the power minus 10 to the power positive 18 electrons. So first topic is completed. Electrical substance are of two types: one conductor, semiconductor, of nearly 1 to 3 types: conductor, semiconductor, and insulator. It can be further classified as follows, but in our syllabus there are only conductors, insulators, and semiconductors. So conductors are generally metals, because metals have greater atomic size, bigger than non-metals. Metals have greater atomic size than non-metals, and if atomic size is big, then the force exerted by nucleus on the electron will be less. It will be force is inversely proportional to size. If force size will increase, the force which will decrease. So the substance permit electrons to flow freely from particle to particle. Yeah, is lesser the force, the electrons move freely particle to particle. An example are copper, iron, silver, aluminum, etc. Due to presence of more loosely bound electrons. A loosely bound electron means the free electrons which can not ride by the force by exerted by nucleus, because it can atomic size is big, so that due to presence of more free electrons, the conductor conduct electricity. And semiconductor are the material that has no electrical conductivity value falling the electricity conductive value falling between that of conductor, such as insulator, such as metallic copper, CO, and an insulator such as glass, such as CS, gas, titanium dioxide, etc. Due to presence of less free electron, it can conduct electricity half-half. So the next topic is insulator. So into insulator are the substance or molecule that resists the flow of electron. Insulators are the materials that resist the flow of electron, means oppose the flow of electrons from atom to atom and molecule to molecule, e.g. wood, glass, cloth, etc. This is a common example of insulators are which we, or we can say uh, due to the presence of more loosely bound electrons. Due to absence of more loosely bound electron, means in insulator there are only some or no loosely bound electrons, so that it can't conduct electricity. Generally, non-metals are insulators because their atomic size is smaller than metals and always smaller, and the force exerted by nucleus is greater on the electrons of insulators. And, and charge in motion. So, charge in motion electric current, it means that the flow of charges means flow of electrons is called electric current per unit time. The current can be classified as charge upon time. So I is equal to Q by T. I is a symbol of current. We have studied the quantization of charge. There is quantization of charge. So there it is Q is equal to NE. There we can see that Q is equal to NE. So that it is sign of charge is Q T, and there is NE upon T. The formula which is back page. Yeah. So I is a scalar unit. Electricity is a scalar quantity because it only have magnitude, no direction. SI unit is ampere, and 1 milliampere is equal to 10 to the power minus 3 ampere, and 1 microampere is equal to 10 to the power minus 6 ampere. I is equal to Q by T, and NE upon T is equal to rate of flow of charge through a cross section of a conductor. Cross section, it doesn't mean very complex thing. Cross section is when we study a thing with the help of a wire and cross the section of wire, then we have studied it. And this is a numerical, so we don't have to. Yeah. What constitutes the electric current flowing in circuit? It means that why electric current flows in a circuit. It is due to some uh, external external agent like a potential difference. What is potential difference? Free electrons in the conductor flows through the wire, which constitutes the flow of charge as electric current. Means the free electron present in the conductor flows through wire. The electron flows through wire, which is free, and constitutes the flow of, yeah. This is called the charge as electron. The concept of voltage. So why does the electric charge flow? Due to presence of potential difference across the ends of conductor. Uh, It means that the electric charge flow due to the presence of potential difference across the ends of conductor. A potential difference, other words, is voltage. Voltage is equal to work done upon charge. There is an example. There is a higher potential point which is positive, and there is a lower potential point which is negative. The electron flows higher potential to lower potential. You can see that. This is the attraction and this is repulsion. This is attractive and this is repulsive. So potential difference. The amount of work done required on a unit charge, the amount of work done required on a unit positive charge to move it from one potential point to another potential point. In other words, the work done on a charge by the battery to move it from high potential to low potential is called the potential difference. 1 volt is equal to 1 joule of work done on a unit positive charge, and move it from one point to another is called 1 volt. V is equal to W by Q. So 1 volt is equal to 1 joule upon 1 coulomb, and joule per coulomb is called volt. Electric circuit. Electric circuit is basically a closed path in which the electric wire, in which the electricity flows. A continuous and closed path made up of wires on which an electric current runs. An electric circuit consists of electric devices like source of energy, wires, and that connect with the help of a switch. It's very common. Electric cell, there is a sign. You can see that. Let a screenshot of it. Electric cell, there is a diagram. All the nine things. Yeah, a meter measures the current in branch, and voltmeter measures current across device. Means a meter is connected in series, and voltmeter connected in parallel. And yes. And what is Ohm's law? Ohm's law is equal to basically this. This is Ohm's law. This is the V is equal to IR. This is Ohm's law. So that there is a blur thing. The Ohm's law states the current flowing through a conductor is directly proportional to the potential difference across the ends of the conductor. Means the current which is flowing in the conductor is directly proportional to the potential difference across the end of the conductor at uh, constant temperature. Means the temperature remains same and conductor remains same. So in this case, voltage is reactive percent current, while the V is reactive percent I. If we want to change the proportionality sign into equal to, we need to add a constant which is R is equal to resistance, which is a constant. You can see that. So the formula becomes of Ohm law becomes V is equal to IR. So what is resistance? There is resistance, but there is also resistance. Resistance is denoted by R, and SI unit of resistance is ohm. And there is a symbol. You can see that symbol. Yeah, opposite of U there is symbol. Basically, resistance is opposition offered by the conductor in free flow of current. Means let's suppose there is a current which is flowing freely, but there is a resistance which can oppose the flow of current. And factors affecting resistance. First is length of the wire, which is denoted by L, and the unit is there is meter. Means the symbol is M. And cross section area of wire, which is denoted by A, means area is denoted by meter square. And material of the wire is the resistivity, which is denoted by ohm meter. And temperature. So resistance, R is directly proportional to L, and R is inversely proportional to area of cross section. So there we can see the result. R is directly proportional to L upon A. So if we want to change the inversely proportional sign into equal to, we have to add constant. There is a constant resistivity. So R is equal to rho L by this. There is rho symbol of resistivity. So SI unit of rho. So rho is equal R is equal to rho L by A. So let's suppose all we have to do read all the SI units of their symbols. And so R is ohm, rho there is rho, and L meter, and area meter square. So meter cut. So rho minus M, uh, meter cuts. Rho minus M is equal to P, मतलब yeah, rho meter. There is a case which you can screenshot it. Most important questions which are frequently asked in words. There is this. You can go through this. Just easy question, some logical based thinking. There is the solution. There is nearly fifth case, and this is a graph which can VI graph, मतलब voltage and electricity graph. Yeah, there is, you can see that. And there is a difference between resistance and resistivity. And resistance is opposition offered by the conductor in the path of electric current flow, and resistivity is basically property of a material to offer resistance in the flow of current. It depends on area of cross section. It depends on nature, material, and temperature. Okay, so there is series circuit. I is equal to same, we divide. And derivation, there is derivation, you can see that. Basically formula application of V is equal to IR. This is a diagram of series circuit. In the parallel circuit, there is I should be divided and V remain same. This is derivation, basically application of Ohm's law, and this is diagram. Three effects of current are chemical effect, magnetic effect, and that is heating effect. Chemical effect is current is pursued through the conducting solution. It causes chemical reaction as cathode and anode. You can see the hydrogen gas uh, electrolytic decomposition process. Magnetic effect. Magnetic effect is current passed through a conductor. Magnetic field is produced through a conductor. We can study it on next chapter. Heating effect is applicable. Heating effect is applicable. Heating effect of current. Current passed through a conductor due to repetitive collision between moving charges. It means the kinetic energy and atoms heat energy, and its power is dissipated and it causes heating. Joule's law of heating. Heat produced in a conductor is directly proportional to the square of amount of current flowing, resistance of conductor, and time. So there is a formula H is equal to I square RT, and this proof. This there is, you can see the proof. Screenshot it. Yeah. There is numerical. There is practical application. Electric bulb made up of tungsten filament. This pure metal melting point is high, so the bulb will glow and heat retention. So glass cover of the electric bulb is argon. Argon is then basically noble gas. And two is electric fuse. SnPb alloy and copper nickel alloy is made up of fuse wire. Low melting point of the when current exerts a certain value, it can breaks the circuit and the melts, and it will pretend or protect from electric short circuit. Heating element is nichrome alloy. Alloy resistivity is greater, so resistance is greater, so heat is greater. So electric power is equal to P is equal to W by T. It can denoted by this energy upon time. Energy is equal to P into T, power into time. Derivation, there is derivation, and electric energy. So P is equal to ET is equal to P into T is equal to VIT is equal to I square RT is equal to V square upon RT. There is Joule's law applications. So common unit of energy is connected. Commercial unit, we can say, is kilowatt hour, kWh, which is used in trade. Kilowatt hour is equal to 3.6 into 10 to the power 6 joule. And SI unit joule, this energy is SI unit is joules, and arcs, and practical unit is calorie. There is some numericals, you can see that. Yeah. So thank you for watching the video.